Hi everybody, welcome here. If you are looking on this from the record and you missed it, I'm sorry. I also didn't know that it was moved here. So, yeah. So let's talk about ZeroMQ. I will start with one quick poll in the audience. Who of you already wrote some network application that has to communicate over the network? Okay, so not so many people. And did you enjoy it? Not so much. Okay. So ZeroMQ will be about writing network applications. And it will be writing network applications in a way that I hope that you could enjoy in the end. So let's see what are the obvious answers when you write network applications. There are these Unix sockets that are quite low level. It's hard to use if you ever tried it. And you have to do pretty much everything by yourself. It gives you quite some freedom in doing stuff, but it's quite tiresome if you just want to make your application work over the network and you are not so interested in networking. You just want to pass data from one end to the other and you don't care what's on there, if there are some trolls running around. Then there are other options. One of pretty well-known one is AMQ. These are some message-based. It has plenty of patterns. It's well-known in Java world, and mostly it's in Java, and it has heavy broker, and it's not so actually easy to start with it. You need to read a lot of documentation before you can write your Hello World applications. So basically that's all I know about it, because when I was trying to start with it, I got discouraged before I finished my Hello World application. So, what is ZeroMQ? It's easy to use, it's fast, asynchronous. It's also message-based, so that's part of the being easy to use. And you don't have to have a broker. You can do all the fancy patterns, but you can do them even without the broker. And yeah, it has quite active community. Project is on GitHub. They are merging pull requests quite fast. One of the philosophical ideas of one of the main guys behind ZeroMQ is that master should be quite stable always, and you shouldn't wait for pull requests to get merged several days. So everything gets merged quite fast, and they are actually not breaking so much stuff. And if they do, they fix it quite fast as well. And it has some other interesting features, and it has some libraries around it that are also interesting. We will talk about it later. And it's not only available over the network, you can use it as IPC protocol as well. So you can communicate between processes on the local machine as well. And when you grow, and you no longer manage to do it on the single machine, you just change the connection strings from IPC to TCP, and you are ready to deploy in the network. And one of the interesting stuff is, here is a list of languages, language bindings that are supported for ZeroMQ. And for quite some of them, they also have examples in their cookbook to help you get started. So whatever language you like, probably it's somewhere in there. Yeah, there is even Haskell. No. I haven't packaged, I think none of them, but my friend did some of them, mainly C and C++. Okay, so some general recommendations from the project. If you are doing distributed systems, they are hard. So one of the philosophical points of view behind ZeroMQ is try to avoid complexity whenever it is possible. So that's why it doesn't have a broker, because it's single point of failure by default. And yeah, if you want to do some type of patterns or some type of communications, you cannot do them without a broker, or it is much easier to do them without with a broker, but you shouldn't put much of the functionality inside the broker. And another nice recommendation from them is it's much better, and it will help you in the future to actually be prepared to recover from disasters when some of your nodes or broker go down, than to try to optimize not to have those disasters. You cannot avoid some malfunctioning or something crashing, but it's always good to have a plan for recovery and test that you can recover. And actually, for ZeroMQ, there is this low-level ZeroMQ library, but if you want to use it, I would highly recommend using CZMQ, which is also in C, but it's much higher level, and it's even easier to use than ZeroMQ itself. And it has some other features we will talk about later. And as said previously, it has some patterns that you can use similar to AMQ, but you should try to use the simplest pattern that fits your needs, because in the cookbook there are really complicated patterns, and you could get really dug down into all those patterns and ended up choosing between tens of them and implementing something that is really hard and hard to change afterwards. So try to keep it as simple as possible. So now let's see some example. This is some hello world example in Unix sockets. And I actually had to get rid of some of the error handling and stuff like that to fit it on one slide. And I'm not sure whether you understand all of it, but, well, probably with enough time you will. But it's really unreadable and not so obvious, I would say. Maybe for somebody it's developers friendly, but for me, it's not so much. So another hello world, this time in ZeroMQ. And here you see that we will just open ZeroMQ socket with some type. We will connect it, and then we will send hello, and we will wait. We will receive something back and print it. So the API is quite straightforward and quite simple and quite readable. So I started with a type of socket. What's going on? I think it's getting somehow darker. Do you see it as well? Okay, so strange. Did I step on something? No. No? No screensaver involved? No, let's. But something is better than nothing, I would say. Okay, so in the example previously, you saw that there was some magic constant ZMQ rec. And this specifies the pattern that we are using. So let's see. Okay. Is it same on your computer? Okay. Weird. Okay, so the simplest pattern that you can use is request reply. You've got some client, he requests something from the server, and he will get reply back. That's simple. But there is also other pattern that is quite frequently used and that you might be interested in, and that is more complicated, and that is publish subscribe. And here you have one server and multiple of clients, and all the clients are subscribed to the messages that the server is pushing. And in ZeroMQ itself, this pattern is asynchronous, and you don't have guaranteed delivery. So if you are pushing too many messages and there is a slow line somewhere in between the server and the client, you can lose some of the messages. But yeah, it's quite nice if you need to subscribe multiple clients, and if you need reliable delivery, then probably you need a broker. There are also other interesting parts of the ZeroMQ stack that you can use. There is something called Z-Actor, that's a thread abstraction library or object to help you with abstracting over the threads. And it's actually used internally if you are dedicating some port, or if you are dedicating some worker to process messages. Z-Polar, that's another structure that iterates over several sockets. And if you are listening on multiple ports or multiple addresses, then it will give you which one received the message. There are normal structures that can be useful, like hash table, list, linked list. Other interesting features that are there is Z-Beacon and Z-Gossip. Z-Beacon is used to discover other nodes inside the network. It's using UDP. And Z-Gossip is gossip. So basically, you've got one node that has some knowledge, and it connects to another node, and then they exchange the key value pairs, and it tries to get all the network synchronized in the synchronized state by exchanging information between the peers. And one of the new additions, which started last year, is Malamute, and that's a simple broker focused on enterprise features that enterprises need usually. So, a little bit about the broker. Yeah, it supports some simple authentication, so you can have a list of login names and password on the broker itself, and it wouldn't let clients communicate unless you match these credentials. But this authentication is just a simple example of what can be done. It doesn't support any LDAP logins and stuff like that. Compared to pure ZeroMQ, it supports a reliable publish-subscribe pattern. So even if there is network problems between your publisher and subscriber, the broker will keep the queue of the messages, and you will get it once you are reconnected back. So you are not losing any messages. it supports simple request reply, so you can communicate between the clients without knowing their physical address, but by knowing just their name inside the system by the name that they presented to the broker. And to make it reliable and working, it supports heart beating, so when your client is no longer there, it will disconnect it, and yeah, you can reconnect back so messages don't get lost. And it also supports something called services, which is a common queue for multiple workers. Imagine that you have multiple machines that can process requests, and you are getting requests from the network, and these requests are queued on the broker, and any of the workers can fetch the request, process it, and send the response back. So that's the third pattern that this simple broker supports. But there are also some other interesting tools that we can use with ZeroMQ. One of the most interesting tools, I would say, is called Zproto, and it's code generator. And it's unfortunately XML based. Nobody likes to write XML, but it's quite powerful. It's based on GSL, which is some code generation tool. And from this XML template, it will generate you CZMQ code. And it can be used, for example, if you are developing some protocol that you want to communicate between your machines or processes, then you just describe the protocol and it will generate all the handling functions to encode messages, to decode messages, to operate with them, to send them over the network and stuff like that. And apart from that, it can also be used to describe a state machine, and then you can generate all your code and basically just hook up on the correct handling functions and avoid all the boring stuff that is involved in most of the programming, like writing state machine from the scratch for the 100 times. Yeah, it helps you get started much faster, and you can throw away your code and start from the scratch again. So let's take a look at how it works. This is an example of message that could be described. It has some name and it has some fields. The fields can be either string, or in this case it's dictionary, so basically hash table, or it can contain another message. So you can create message and then put it inside another message, and so long and so long and so long. So this is pretty simple, right? Yeah, pretty obvious what to do. And then you run code generator, and you would get some API functions that you can use. You can create a new message. You can encode it with all the fields filled, or you can just set one of the fields for strings. You've got nice printf format, so you don't have to sprint it to some buffer and then put it there. You can directly call this function, which is really nice and convenient. And there is also possibility to just directly send it somewhere. Pass it the socket that you created and send it around. So, what else? Now, this is a description of the state machine. We've got some state, we are connected, and if somebody sends us subscribe message, we will store it and we will reply, yes, you are subscribed. And there is also another state which is inherited in all others. And if somebody sends us a message that we are not handling, then we reply that it's invalid, and if we got expired, we will terminate the client. So this is not so easy as the protocol itself, but it's still quite understandable. And if you run a generator, you will get hundreds of lines of code, which is much less readable. And this is what you get. You will actually get actor. That is one of the abstractions that I spoke about earlier, this thread abstraction. And you will just create a new server and tell it to bind somewhere, and it started. It's working. It's listening for the connections, and when it receives the messages, it will switch between the states and do whatever you told it to do. As you noticed in the previous slide, we said that there is some action like subscribe client, and yeah, the generator doesn't know what we mean by that. So it will just generate some stub functions, which are by default empty. Then you can go and fill in those. And during the generations, these are not going to be overwritten, so they will stay, and you just fill in the functionality that is behind your application. You fill the logic itself, not the boring part about handling various states and switching between them and stuff like that. You just handle the really important logic that machine cannot do for you. So, okay, it disappeared again. Okay, so there is something called zguide. The URL is zguide.zeromq.org, or there is github.com/zeromq. You can go visit those sites. The first one is quite a lengthy book describing various patterns that you can use with ZeroMQ. It also contains examples in quite some of the languages that were mentioned at the beginning. On GitHub /ZeroMQ, you can get CZMQ, ZeroMQ, other bindings and other related projects like Zproto. There is also Z-project. Z-project is another interesting code generator, but it generates CMake and automake files if you don't want to write them by hand. So yeah, check out those. zguide to find some easy examples, how to start playing with it, and GitHub if you want to see some more interesting projects that are related. So, and that's all I've got. Now let's go to your questions, and I will try to answer them. And we will see if I will manage. So, who has a question first?
So, is the ZeroMQ based on some standard message queuing protocol, or is this highly implementation specific?
It has its own protocol, and basically you can generate your own. The format is pretty simple. It's just a stream of bytes, and if you generate using Zproto, you can read the resulting code, and it's really simple what's going on the wire. One of the things that they proclaim as their advantage is that you can write a parser of ZeroMQ messages quite easily. So they are not complicated. They are simple, but not anything standard. What protocols does it use? Yeah, you can specify whether you want to use TCP, UDP, IPC. IPC is not available on Windows. It's also multi-OS thingy. So, yeah, TCP, UDP, IPC, and might be some others, but these are those that I try to use. Okay. So, question about Python implementation. I'm not using Python myself, but I have a friend who is really interested in Python, and he wrote some code in Python to help him test what we wrote in C. So he said that it was quite nice. I think that API would be kind of similar to the C one, CZMQ one, but there will be probably some differences based on the language. I haven't seen it by myself, but I know that it's quite simple and usable as well. Because, yeah, this friend of mine really liked it, so. Well, if you are using the Python, you are using probably Python bindings, and those Python bindings probably depends on ZeroMQ C library. But one of the reasons that, from what I understood, using C as a language has big advantage that it's easy to write bindings in every other language for it. So that's what they did. But you don't have to touch C by yourself. You can just install the Python bindings and use them. And by using Python bindings, you are still compliant. Well, the messages that you will send will be still received well by other implementation of CZMQ or ZeroMQ. We were on the Hackfest that happened in Brussels, and there were plenty of guys writing in C, C++, Scala, Python, Go, and we all were able to communicate with each other without any problems. Yeah. So, some other question? Yeah.
You know, implementations, you mentioned AMQ in the beginning, for instance. What about MQTT? Are there any particular advantages that ZeroMQ has over it? Or, you know, do they have different use cases? Is there, you know, any way to decide whether to use one or another?
So, question was regarding how to describe it in regards with competition. So, yeah, I tried to look at AMQP or AMQ, and I found it quite difficult. Actually, the guy that wrote this, the ZeroMQ, was part of the AMQ standardization committee, and he knew what they did wrong, so he tried to fix it by writing this. The other MQTT, that's the IoT thing. Yes. Yeah, that's quite new, and I've seen some high-level overview, but I have no more knowledge about it. I just know that it's new IoT thingy, and we can do a bridge to our ZeroMQ. So. RabbitMQ, I think it's similar as AMQ, right? It's the same protocol, but different implementation, right? Yeah, so the answer was for the video recording, it's Erlang written, we don't know much about it, and it's AMQP as well. So yeah, it's AMQP as well. And in Erlang, it should be much easier than the Java bindings that I tried, but probably as it is AMQP, you still need the broker, and it's quite complicated inside. And yeah, same comment as the previous one applies. This guy was, the guy that wrote this was the guy that was working on original AMQP standard, and he found out what was wrong, and he found out that it's impossible to change it in the standard anymore, so he decided to drop it and write something from the scratch. And yeah, the whole philosophy of this is keeping things as simple as possible to avoid complexity, because with complexity comes bugs, and with bugs comes instability, and it's getting harder and harder. And with complexity comes also overhead. So they said that they are much more faster than those solutions, but haven't tested it by myself.
Is there any effort then to create a new standard or new revision of the standard that will cover ZeroMQ and allow some interoperability?
Regarding, okay, question was whether there is some effort to create a new standard. I don't know about effort to create a universally recognized standard, but ZeroMQ is developed around the GitHub and around RFCs. So they have RFCs describing the protocol, they have RFCs describing how their development model works. So they have plenty of documentation which you can use to basically implement it from scratch if you want, or to inspect the protocol, or do whatever you want. So they have their own documentation in form of RFCs. Okay. Does it support encryption? Yes, there is this curve elliptic thingy that I don't understand at all, but it is supposed to be quite secure. It's using libsodium library for this. And I haven't used it, so I cannot answer the details of which parts of the messages are encrypted. But I know that it is supported there, and it should be easy to use. I just haven't had the need to do it yet, because we are currently in development phase of our project, and we are not doing final deployment yet, so we don't need encryption yet, but should be pretty easy. I used libsodium to do some other encryption, and their API seems really simple and useful as well. Okay. Anything else? No? Then thank you for your attention, and see you around.